Welcome back. It's Craig Maynard. I'd like to speak to you now about physics. So we're going to look at ways we can create objects that have physical attributes in Robot Studio, attributes like gravity and collision and things like that. So we can have objects that interact physically, like a real world, with each other in the Robot Studio environment. So to do that, let's just create a few objects. Of course, I could bring these objects in from SolidWorks, but in this case, I'm just going to bring them in to Robot Studio and create them in the modeling section. So let's start by making our robot invisible. We have an IRB 140, the operating system's running. We've got a green light down in the corner. Let's create a couple simple objects and play around. Modeling. Well, first thing I'd like you to try doing is go to create a box. Let's create a box that's, let's say 400 by 400 by 400. Okay, we'll just create that box, and we'll just call that box box. And let's take the box, go to Home, choose Move, and we'll just do a linear move on this just to get it off the origin. Awesomeness. All right, shut that down. Let's go to back to modeling again, and we're going to create let's create a cone. We'll create a cone with a radius of 200 and a height of 400, of course, a diameter of 400 and a height of 400. There's a fine looking cone. And let's make a copy of this box just so we have another object to play around with. So we're going to take this box, and I'm going to say copy, right click on it, go to my solution, I'm going to say paste. We have another box, and we'll say paste, and we have another box, box 2 and box 3. Awesome. We'll just move box 2 over here, and we'll move box 3 over here. Okay, so we have 3 little boxes, as you can see, and a cone. Now let's put some physics on these boxes and the cone. So starting with the cone, which we haven't renamed yet, let's just make things a bit more self-documenting. We'll call that cone. If you right-click on the cone and select physics and behavior, you notice there's 4 different kinds of behavior. There's inactive, fixed, kinematic, and dynamic. Inactive means it has no physics at all, and it's basically just a phantom in space. Objects will pass right through it. A fixed object does have, it does interact with other objects, but it's fixed, it's permanent. You can't move it, so an object would bounce off it or roll off the top, but it wouldn't actually move the object itself. Kinematic, that refers to an object that's got some mathematics behind it. For instance, a robot is a kinematic object. It has, the intelligence of the robot and can move around like the robot. It can move objects, it can interact with physical objects, but it itself can't be moved by a physical object. Dynamic is making the object itself controlled by all the physics of the situation. So let's take our cone and we'll make it dynamic. So our cone is now dynamic, and we can actually move the cone around. So the best way to see how well it works is to run the simulator. But if I play the simulator right now, just the way it is, the simulator will just run for a second and stop, because there is no program loop in here. So the program runs and there's nothing in it, and it stops. So if we want it to run continuously, we should go to Simulation, the Simulation tab, and choose Simulation Setup. And in run mode, tell it to run continuously. It should keep looping around now. So now if we run, you run simulation again, like this, simulation should be working just fine, and our object seems to have hopped away for some reason. It seems to be shy. So let's choose the Freehand Drag, which is now a feature because we have a physics object. And I can grab this object by its end, and you can see that the object moves around. So I can grab that object again and move it around, rings like a bell, getting a little excited here. I'll just let it go, and it hits the ground. Now sometimes it's better to move the object while the simulation's turned off, so you can see I can move the object all around now. in space. So let me take the object here. We'll choose, let's grab it by the endpoints. Right, so now you can see I can grab it over here, I can move it over here. Let's see if I can get it over top of that box now. Looks like it's sort of over top of the box. And if I drop it, it falls right through the box because the box itself is inactive. Okay, so we're going to take that object and I'm going to drag it away here. And let's take this box and we'll change the physics of it. Let's change the physics so its behavior is now fixed. So if it's fixed, I should be able to take this object right over top of the box and let it go. And now you see the object bounces off the box. Okay, I'm going to turn off the simulation so the cone should behave a little bit better. Let's see where it is now. Oops, simulation off, please. Okay, that little green line has gone away over simulation, so it's now off. And let's see if I can drag it over top of the box. You can try this too on yours. Okay, and it's right over top. That's great. Now we'll just run the simulation, play, and the object just bounces off the box. And if you're clever enough, you should be able to actually get this to stay on top of the box if you can get it just right. Easier said than done. Here we go. You there? All right. Yeah, it's a bit of an art form. You got to see it in both dimensions. So let me pick this up again. I'm going to put it over here, and I'm going to put this one over here. Just drag it over there and drag it over there to the left. Come on. There we go. See if I can get it to stay on top of the box. Okay, this might work. You press play. Boom. And now the object is on the box. And this one here is still inactive, so let's take this one right now and we'll modify it. We will modify it by checking its physics behavior, and we'll make it dynamic. And now I should be able to pick up this part. Am I still running? Yes, the green is still over simulation, so I'm still running my simulation. And I can pick up this object and knock my cone off the box. There we go. A little bit of physics going on. Now a little interesting experiment we can do again. Let me just take this and I'll put it over here. I'll stop the simulation. Let's go to modeling. And we'll create another solid. So we'll put a box in here. And let's say the box is 500 long, 500 wide, and 10 millimeters high. We'll create that. That seems to be a little small. So if I go to my part here and let's modify it. We'll just delete that one and we'll start over again. So model a solid box. Let's make it 5,000. That's pretty big. And we'll make it 400 wide, and we'll make it 10 wide. I'll make it a little higher. We'll make it 10 wide and 500 wide. There we go. Close that, and now we have another one, which I'm going to rename slide. Okay, so we have a slide at this point. And this box right here, I believe this, I'm just going to delete that one for now. Let's take the slide and we're going to rotate that. So we'll take the position, we'll rotate it, and and let's say 10-degree steps on the, I think the y-axis would be the axis in and out. So let's rotate it on the y-axis. Oh, and we'll make it minus 10 degrees. We want to go the other direction. So we'll apply and apply, and then we have a nice sloped surface right there. I'm going to take this sloped surface and we're going to change the physics of it to make it fixed. Now I'm going to create another solid. Let's just make a sphere, and we make that sphere 200 in diameter. Create it and close that. Rename that sphere. And let's take that sphere and change the physics of it to make it a actual dynamic object. Let's take that same sphere and let's change the material to, let's make it like a rubber. Sounds good. And while we're here, we can apply other characteristics to it. Let's make it a red sphere. Okay, we can modify the graphic appearance of the sphere. So we can take the material, apply a certain material to it. How about something that gives us a nice, obvious roll? That looks good. I like that. Okay, so now we have a interesting texture on our sphere. There it is. And we should be able to, if it's physics enabled, we should go back to home, and now we have our freehand drag. So let me just drag the sphere over. And let's see now, it looks like it's just about ready to go up that ramp. I'm going to drag it up to the top of the ramp here. Are we still on the ramp? Okay, I'm going to put it over a bit. There we go, like that. And let's have some fun by putting it right at the bottom. Oh, yeah. Right at the end of the ramp. Okay, and a little down maybe. There we go. So let's see how this is going to work out. So we'll turn simulation on. And there goes our ball. And of course I can go to my freehand drag and I can drag that sucker all over the place. Anyways, that's a little bit about physics. It's a very powerful tool, very interesting. We can also create physics joints if we want to. So we could have two objects with a joint and they pivot around the joint. We can rotate. It can be a prismatic joint, which allows you to move linearly along an edge. A ball joint would be one that rotates like a ball joint. Or we can lock two objects together using lock joint. So let's see if we can do that. We'll do that in another simulation. So what I'd like you to do is go ahead and play with some physics until you get used to it.